Do you feel like working a third shift at a call center for the next 5 years to purchase a monster truck you can use to grind your math textbook into dust? That's awesome. We can help you avoid those sleepless nights with this video from Fort Bend Tutoring and Mr. Witt.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about how to find horizontal asymptotes when dealing with rational functions. Alright, so when you're dealing with rational functions, you are dealing with this form right here. You have a function which could be named f of x that equals to a function divided by another function. So these functions can come in many different forms, but this is going to be the format of any rational function. And always keep in mind that the function in the denominator can never equal to 0 because that would make the entire thing undefined. So you can never have 0 in the denominator of a rational function, aka a fraction. Alright, same rules apply. So now let's look at how to determine a horizontal asymptote. Alright, so how to find a horizontal asymptote. The first thing you want to do is identify the highest degree in the numerator and the denominator. If necessary, you may need to multiply, alright, to make that happen. So that's your first step. Secondly, if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is going to be y equals 0. That's right, it's going to be the x-axis. Yeah, that's what you're going to be using as the horizontal asymptote in that case. Now let's take a look at step 3. Alright, in step 3, if the degree in the numerator is greater than the degree in the denominator, you won't have a horizontal asymptote. Nope. It just won't happen. See, when you're dealing with rational functions, at most you'll have one horizontal asymptote. Otherwise, you just won't have one. Alright? The function doesn't have to have a horizontal asymptote. So you may not have one in yours. So you can have either one horizontal asymptote or none. And speaking of asymptotes, the asymptote of a graph is a line where the graph approaches but never touches the further out you move from 0. Alright? So as you move further away from 0, the function will get closer to this line, whether it be a horizontal line, a vertical line, or a slant line. Your function will approach this line closer and closer but never touch it. So that's what we're looking for in this video, a horizontal asymptote. And now for the final step that you should be aware of. If the degree of the numerator is equal to the degree in the denominator, you're going to simplify the terms with the highest degree and ignore every other term. Just ignore it. You just want to take the terms that have the highest degree and simplify it. So that means that the rational function that you're looking at is not in its factored form, that you've multiplied it all the way out, alright, to identify the term with the highest degree in the numerator versus the term with the highest degree in the denominator. Okay, so now that we have all the rules on the table, let's go ahead and apply that in some problems, right? So here we have problem number 1. Okay, so I have the function f of x equals 1 divided by x minus 4. In the numerator, it can be noted that this equation can be written as x to the 0 power divided by x to the first power minus 1. I'm rewriting it that way to identify the fact that my highest degree in the numerator is 0. It is. Whereas the highest degree in the denominator is 1. So remember, x to the 0 power equals to 1 as long as x does not equal to 0. And in that case, we're assuming that it doesn't. Your degree in the numerator is less than the degree in the denominator. Alright? So we're looking at the degree of the polynomial in the numerator versus the degree of the polynomial in the denominator. The degree of the function in the numerator versus the degree of the function in the denominator. In this situation, we clearly see that we have a smaller degree in the numerator versus the denominator. In this case, your horizontal asymptote is going to be the equation y equals 0. That's it. I'm going to red box this. That's right, I'm red boxing it. Red boxing my answer. So we found out that in this rational function, the highest degree in the numerator is 0 versus the highest degree in the denominator is 1. Therefore, we're looking at a situation where the numerator's highest degree is less than that of the denominator. Anytime this situation occurs, your horizontal asymptote will always be y equals 0. Now, not only do I want to show you how to find the horizontal asymptote, I'm going to show you how to graph it. So let's check it out on our next page. So here's our original function here. We know that the horizontal asymptote is the equation y equals 0. So we want to graph that equation on our graph right here. All right. So in order to graph your horizontal asymptote, use dashed lines or dotted lines to identify where the horizontal asymptote is. Never use a solid line because your function will in most cases avoid the line. I will say that when you're dealing with horizontal asymptotes, the function can cross, aka touch, the horizontal asymptote, but in most cases it will not. It's only when dealing with vertical asymptotes that your rational function will always avoid the asymptote. Horizontal asymptotes and slant asymptotes, the function can cross over, aka touch, the actual asymptote. You're going to have a dashed line going right through the x-axis. All right. So there you go. That's going to be the graph of the horizontal asymptote y equals 0. Use dashed lines or dotted lines, but never a solid line to graph your horizontal asymptote. And that's it. That's problem number 1. Okay, in problem number 2, we have h of x equals x minus 1 divided by 2x cubed minus 2x. What we're trying to identify here is the highest degree in the numerator versus the highest degree in the denominator. If I were to rewrite this, I can show that in the numerator I have x to the first power minus 1 divided by 2x cubed minus 2x. This shows that the highest degree in the numerator is 1 versus the highest degree in the denominator is 3. So that means that my horizontal asymptote is y equals 0. Remember that anytime your highest degree in the numerator is less than the one in the denominator, your horizontal asymptote will always be y equals 0. So let's go ahead and show that. Y equals 0 is the horizontal asymptote. That's it. You got it. Done. Boxing it up. All right, let's go ahead and graph it. So here we have our original function. My horizontal asymptote, once again, is y equals 0, and I'm going to graph this on the Cartesian plane, the rectangular coordinate system, aka my graph. All right, so it's just going to be a horizontal line right through the x-axis, that y equals 0 line, and done. That's problem number 2. Moving on. In problem 3, we have f of x equals x plus 2 divided by x minus 2. So in this problem, if I were to rewrite it to show what the degree of the numerator and the denominator is, I can show that in the numerator, the term with the highest degree is 1, and then in the denominator, the term with the highest degree is 1. So therefore, the degree of the numerator is 1, and the degree of the denominator is 1. So this is the first time we have a problem where the degree in the numerator and the degree in the denominator is the same. All right, so what did those rules say about a situation like this? Exactly. We're supposed to ignore the other terms and simplify the terms with the highest degree. So that means I'm simplifying x divided by x. Well, x over x, assuming that x is not 0, is equal to 1. And that's it. So your horizontal asymptote is going to be written as y equals 1. That's it. That's the equation for the horizontal asymptote. Done and done. Red boxing it. Red boxing it. Y equals 1 is your horizontal asymptote. All right, let's go ahead and graph it. So once again, we have your original equation, and our horizontal asymptote we found is y equals 1, and we're going to graph that on our Cartesian plane. Alrighty, so we have a dashed line going right through the line y equals 1. All right, just like that. That's your horizontal asymptote for this equation. That's it. All right, moving on to our next problem. In problem 4, we have the equation f of x equals 2x squared plus 1 divided by 3x squared minus 4. So once again, we can see that the degree in the numerator and the denominator is the exact same, because our highest degree in the numerator is 2 based on the term 2x squared, and the highest degree in the denominator is 2 based on the term 3x squared. So we're focusing on the exponents on the variables. That determines the degree of the polynomial. And in every case, you're looking for the highest degree. That's why it's important not to leave any of these rational functions in a factored form when identifying your horizontal asymptote. It makes this process more efficient and more accurate to have everything multiplied out. So here's the deal. What are we to do now? So your next step is to ignore the other terms, that 1 and -4. We don't care about those. You're only going to focus on simplifying the terms 2x squared and 3x squared. Assuming x does not equal to 0, x squared divided by x squared is just 1, so in other words, it cancels out. So my result is 2/3. But in order to write your horizontal asymptote, you're going to write it as follows. You'll write your horizontal asymptote to be y equals 2/3. It must be in the format of a horizontal equation. In other words, it needs to be in the format of y equals to a number. You'll never just submit just a number for an answer when answering the question, what is the horizontal asymptote of a rational function? You'll always present your answer as a horizontal equation, aka the format that you see before you. Y equals 2/3 is the answer for the horizontal asymptote. Don't just give them 2/3, give them the entire equation. Red boxing it. There we go. There's your equation. Let's go ahead and graph this. Alright, so here we have our original equation, f of x equals 2x squared plus 1 divided by 3x squared minus 4, and our horizontal asymptote is y equals 2/3. So, being as though this is a horizontal line, and 2/3 it's almost to 1, so we're going to have it about right there. Alright, there we go. So this is the horizontal asymptote, y equals 2/3. That's problem number 4. Let's move on to problem number 5. For problem number 5, we have g of x equals x squared divided by 4x minus 4. If I were to rewrite this equation, we'll have g of x equals x squared divided by 4x to the first power minus 4. I'm rewriting the equation to show that the highest degree on my variable x in the numerator is 2 versus the highest degree in the denominator is 1. So here we have a situation where the numerator's highest degree is greater than that of the denominator. Alright, well, anytime the highest degree in the numerator is greater than the highest degree in the denominator, you won't have a horizontal asymptote. You won't have one. So the answer to this problem, as far as horizontal asymptotes are concerned, is none. That's right. You don't have one for this rational function. You just don't. Now, to be clear, you will have an asymptote for this function. It just won't be a horizontal one. Anytime your highest degree in the numerator is 1 more than the highest degree in the denominator, like in this case 2 is 1 more than 1, you'll have an oblique, aka a slant asymptote. Alright, so don't forget to check out the video on oblique slant asymptotes. You can check out this link right here. Alright, so check that out. And we're going to red box our answer, because the answer is none. You don't have one. Red boxing it. That's problem number 5 in a can. Well, more like a box. Let's move on. So to recap, there's nothing to graph here because you don't have a horizontal asymptote. So we'll just remind you that that answer is none. Okay. Here we have problem number 6. And in problem number 6, we have f of x equals x squared plus 2x minus 8 divided by 2x squared minus 3x minus 5. Alright, so the highest degree in the numerator is 2, and the highest degree in the denominator is 2. Once again, you're looking at the exponents on your variable x. You want to make sure that you're not looking at the factored form of the equation. You've already multiplied everything out. As you see in this function here, everything is multiplied out in the numerator and the denominator, and I can quickly identify that the highest exponent on my variable x in the numerator is 2. The highest exponent on my variable x in the denominator is 2. Therefore, I know that the highest degree in the numerator and the denominator is the same. So what to do in this case? Ignore the other terms. That's right. Put all your focus on the terms with the highest degree. Therefore, I'm going to be rewriting this to simplify it. This x squared divided by 2x squared. Assuming that x cannot equal to 0, x squared divided by x squared will simplify, alright, aka reduce to 1, to give me a result that is 1/2. That's it. Remember, it has to be in the form of a horizontal equation, aka y equals to a number. So my horizontal asymptote is going to be y equals 1/2. And this is the equation of your asymptote. Done. Red boxing it, y'all. right here. That's it. Y equals 1/2. Let's go ahead and graph it. All right, so we have our original function, f of x equals x squared plus 2x minus 8 divided by 2x squared minus 3x minus 5, and our horizontal asymptote is y equals 1/2. Let's go ahead and graph that. So on our Cartesian plane, it's going to be halfway between 0 and 1. So it's going to look just like this. Remember, your horizontal asymptote is going to be a dashed line or a dotted line, never a solid line. Okay? And there you have the graph of your horizontal asymptote for problem number 6. All right, ladies and gentlemen, so that's going to complete this lesson on how to find and graph horizontal asymptotes. Once again, this is Mr. Witt with Fort Bend Tutoring, FBT. Please rate, comment, and subscribe. And if you're able, please donate, as that helps us bring you more free math videos from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.